Hey everybody, this is Mr. Munson and we are still in Chapter 8, Quadrilaterals. We are continuing 8.2 with Part 2 of this section I am calling Parallelograms, Rectangles, and Rhombi and Squares. Oh my! This video is dedicated to Jillian in my 7th period class who really likes chicken teriyaki. Feel free to pause the video and stare at the picture below. When you're done, let's get started.
All right, so let's take a look at some more problems. And so as we just continue this, some of this is just a matter of being exposed to different kind of thoughts and processes, and then just remembering what your properties are. So go ahead and pull out your properties, quadrilateral properties chart. Make sure it's filled out completely. I sent out a remind that had the correct solutions on it. So if you didn't get that, you want to get that and shade in the chart correctly. Okay, so let's take a look at this. Okay, so it tells us that this is a parallelogram. So all the characteristics of a parallelogram are now true. And if you don't know those parallelogram characteristics, you're going to have to do whatever you need to do to memorize them. And if you can't think of a way of doing it, some people do flashcards, some people it just naturally comes. Then you come and see me, on a Tuesday or Thursday before the test or quiz, and we'll work on that. All right, so let's take a look at this one. If you look, they're asking us to find the measure of BDC, and I have it kind of highlighted there in green. What we have to remember is that in a parallelogram, the opposite sides are parallel. Okay, so we got a whole bunch of numbers in there, 25, 17, 35, and what we have to do is kind of decipher what it is that we really need. So they're looking for this angle here. Well, since this is 25 up here, we know by alternate interior angles that one's 25. There you go. We've got that answer. Okay, let's move on to the next one. Okay, again, we're just going to keep on experiencing the problem. There's no necessary, hey, this is the problem I want you to understand. It's more like, what are some of the thought patterns? What do we do when we're given these problems? We have to look at what kind of shape it is. It's a rhombus, and now we have to kind of walk through what all the characteristics are. So now everything about a parallelogram is true. Opposite sides are parallel and congruent to each other. In a rhombus, all the sides are congruent to each other. The diagonals are perpendicular to each other. The diagonals, of course, bisect each other because they're a parallelogram, and so on. So we have to have a firm understanding of all the characteristics. So again, have your chart out. Let's look at rhombus, and let's see what it is they want us to find. So we're looking for CBD, and I have it kind of highlighted in blue. That's the question they're asking us to find, okay? So let's see if we can think through, how to find that angle. Put me on pause and see if you can come up with it on your own, and then come back and see how I go about doing it. Okay, so one of the characteristics of a rhombus is that the diagonals bisect the angles. This is what I know. The angle I'm looking for is the same as this angle over here. So if I knew what the whole angle was, then I could just simply half it and find out what that is. Okay? So if I could figure out what this whole entire angle is, then I just simply half it. Well, because it's a parallelogram, I know this angle is the same amount. Of course, they didn't give me what that angle was either. But since it's a parallelogram, I know that opposite angles are congruent. So I'm just kind of piecing through and finding the things I can find. And this is a typical strategy I've taught in the past. I don't know how to find this one. I'm just going to start finding the things I can find. Okay, so now I know that those are opposite angles are 40. Well, since it's a quadrilateral, I know opposite angles are congruent. That means both those red angles are congruent to each other. So I'm just going to simply set up an equation. 40 plus y equals 360, right? So those opposite angles, those red angles being y, are going to be equal to each other. So there's two of those, okay? So let's just simply solve for y. So those big angles end up being 140, and so that leaves us for the blue angle to be half of that. So the smaller angle, so the angle is equal to 70 degrees, okay? Okay, let's take a look at this one. Go ahead and try to work on this again on your own. And then if you need help, come back and hear some of my logic. And it might just be getting you started with my logic. And then you can put me on pause again and then try to work on it on your own. And that's how you're going to experience doing these problems. And so just watching me do the entire problem, you're not going to get very far in your thought. You want to be able to struggle and think through these problems, okay? All right, so put me on pause and see if you can do them on your own. So I'm just kind of went through my chart, and listed all the things that I know about the sides, the angles, and the diagrams for a rectangle. So the sides are opposite, the opposite sides are parallel, opposite sides are congruent. Angles, all the angles are 90, diagonals are congruent. And so, of course, there's some other, parallelogram features that come together with this. The diagonals bisect each other. This is more of a rectangle. The diagonals bisect each other, but they're all the pieces are congruent to each other because the diagonals are congruent. And so these are things that I know. So now I'm going to look at the information they gave me, and I'm going to go ahead and write it into the problem. Okay, so I wrote the information in. When they gave me the 25 and the 15, I started thinking, oh, this is going to be a right triangle problem. I was thinking they were going to ask me to find AB. I could use Pythagorean theorem to find AB if I wanted to. Given two sides of a triangle, a right triangle, I could find the missing side, AB. But it's not. They're just simply asking me to find DE. So now that I've gone through my list over here, I remember the diagonals are congruent. So AC is 25. That means DB is 25. And so they're asking me, what is that DE, that segment DE? Well, since it's a parallelogram, the diagonals bisect each other. So half of 25 is going to be 12.5. Okay? All right. Make sure you ask a question in class if you're not sure how that came about. All right, so here we have a parallelogram, so I have to know all the features of parallelogram, memorize, if you need to, have your chart out, or just, let's go ahead and start by putting the information. Okay, so I put the information in. So I start asking myself, what do I know about parallelogram? What's the relationship that the sides have? Well, I know opposite sides are parallel, but I also know that they're congruent to each other. So as soon as I say that things are congruent to each other, that tells me how to write the equation. So I'm going to say that 7x minus 12 equals 4x plus 6. But wait a minute, I didn't use this at all, and that's not our problem. I don't need that, okay? So I'm just going to go ahead and solve that equation, find x. So I find that x is equal to 6, but that's not the question. The question was, what is the length of AB? So I need to remember to go ahead and plug that back in. AB is equal to 30. Let's circle our answers. Okay, so now we're just looking at a bunch of figures with minimal marks placed on it, and then trying to decide, is this a quadrilateral, parallelogram, rectangle, square, or rhombus? Okay, so when we look at these things, when we're naming them, we look for the highest order name. Like quadrilateral is the lowest one, square is the highest one. So if I call something a square, it means it has the characteristics of a rectangle and a rhombus. Okay, so take a look at this figure and see if you can figure out what kind of quadrilateral. It's definitely quadrilateral because it's got four sides. Maybe it's just an everyday quadrilateral, but is there enough information to say that it's something else? Okay, put me on pause and then come back and check my logic. Okay, so here we have it's definitely a parallelogram at least because we have diagonals that bisect each other. In addition, the diagonals bisect each other in such a way that they create congruent parts on all diagonals. So that means the diagonals are the same length. So if it's a quadrilateral where the diagonals bisect each other and each of the smaller pieces of the diagonals are congruent, then it's actually a rectangle. Doesn't look like a rectangle, but that's the information. How about this one? Put me on pause and see if you can think it through. Okay, so I take a look at this. I see it's a four-sided figure. That's good. The diagonals are perpendicular to each other. So that's not enough to call it a rhombus, even though it's a characteristic rhombus. Here's an example of another shape where the diagonals are perpendicular. This is not a rhombus. This is actually a kite. Okay, so you can't just go by that. But what I find is the diagonals. I'm actually going to skip this one. I think there's a piece of information that's missing. I apologize for having you kind of contemplate that. All right, how about this one? Put me on pause and then check out my logic. All right, this is the one I showed in class. It's one set of parallel sides that are congruent, and it actually forces the figure to be a parallelogram. I'm going to quickly show you the logic, but I'm going to assume that you were paying attention in class when I showed it to you. There's a diagram. Alternate interior angles, congruent. By the reflexive property, the blue line in the top triangle is congruent to the blue line in the bottom triangle. By side angle side, the two triangles are congruent. So if you take a look, I have some black line and a blue line here that represents the pieces of the triangle. If you look, these two angles have to be congruent to each other because they're corresponding angles. Okay? Since those two angles are congruent, we find that alternate interior angles are congruent, so that forces these lines to be parallel. And since those lines are parallel and the other lines are parallel, it has to be a parallelogram. If I was you, I would just remember that one. A quadrilateral with one pair of parallel sides, with those parallel sides being congruent, forces it to be a parallelogram. Okay, so this represents two diagonals. There's a figure, quadrilateral, drawn in white, so you can't see it, but these are the diagonals for it. So take a look at the information, see if you can come up with, is it a parallelogram, rectangle, square, or rhombus? So now I just drew in the green line, but that's not the facts. I'm not going to go by the fact of what it looks like. What I know is this. I have a four-sided figure. That's what these diagonals represent, is that I have four vertices and they connect together and create these diagonals. And the diagonals not only bisect each other, when they are bisected, the little individual pieces are the same. We've talked about this in class. This is a rectangle. If you look at the properties of rectangles, diagonals are congruent to each other. That means they're the same length. So when they bisect it, they would create smaller pieces that are the same as well. How about this one? Okay, so this one here is again four-sided figure. I'm not going to go by what the green shape looks like. What I know is the diagonals bisect each other. But unlike the one right before it, the smaller pieces are not all congruent. So it can't be a rectangle. It simply is a parallelogram. All right, try this one. So let me just kind of list what I see. I see diagonals bisect each other, and the diagonals are perpendicular. So I'm going to go to my chart, and I'm going to look at those categories. So I see that the diagonals bisect each other, and the diagonals are perpendicular to each other. So that makes it a rhombus. Okay, now I don't have enough information for it to be a square. So now I'll just simply say this is a rhombus. Okay, now if this had not been the case, but it would have been congruent like that, that meant the diagonals are congruent to each other, the same length. Now that's enough to say it's a rectangle. The perpendicular diameters, would indicate that's a rhombus. Those two facts go together and call it a square. All right, try this one. All right, here you go. We have it's a rhombus because diagonals are perpendicular. It's a rectangle because the diagonals, when they bisect each other, cut them up into congruent parts. So that makes them diagonals are congruent. Those two facts go together, and we call it a square. Okay, so there you have it. Here's your try it problems. Go ahead and run through these. The set of problems in the the 3 category there, they're all review problems. I've given you which videos to go back and look at if you're not sure. Okay, there's no reason not to get 100 on these. All right, we'll see you next time. I'm going to scroll through these in a little bit bigger format for those people that might be looking at it at a smaller screen. So put it on pause if this looks good. Otherwise, I'm going to scroll. Have a good day.